Hello everybody, this is a video about scientific notation. I'll be your host, Mr. Shirley, with a voice that's smooth like butter. Please make a note as you're going through this video. It can be fairly brief, but it's a great idea to keep some of these things recorded. Okay, so title scientific notation, put a date on there so you can keep it organized and within the proper unit. And our learning goal for today, which you don't have to write down, is to express numbers using scientific notation. And again, please feel free to pause this video or go back and play it again to hear my wonderful voice. If you need to hear something twice or you just need a little more time to write something down. Okay, now scientific notation is just a way of expressing numbers using powers of 10. Okay, and typically it's used with larger numbers, often in science, hence the name, but it can be used in other subjects as well. So regular number, 700, just as an example, in scientific notation, it would be written as 7 times 10 to the power of 2. Okay, now many of you might have seen this before in a number of different environments, and if you already know it, that's great. Okay, so to convert a number to scientific notation, there's two main steps that you would use. I'm using an example of 35,000 here to just illustrate it as we go through. So move the decimal place so it's right after the first digit. Okay, so that's 3.5. Okay, so you don't lose any of your numbers here. You're losing the zeros, I suppose. They're getting moved to a different part of the scientific notation number. But make sure you're not losing the 5, for example. Make sure this doesn't just become 3. Okay, the numbers still stay there. You put the decimal immediately to the right of the first digit, so 3.5, and then you have times 10 to an exponent that reflects how far the decimal was moved. Okay, so in our case, the number 35,000 has the decimal right there. Okay, we normally wouldn't write it, but that's where it is. So if we moved it 1, 2, 3, 4 times, we had to move the decimal 4 places. So that means we would have 3.5 times 10 to the exponent 4. Okay, so the exponent reflects how far the decimal moved. Okay, that's all. Now, if the number is 10 or greater, the decimal point moves to the left, just like we did in the 35,000 example, and the power of 10 is positive. Okay, so with our 442, it moves 1, 2 spots, so that means our answer is 4.42. Okay, the decimal goes to the right of that first number, times 10 to the exponent 2, because we moved our decimal 2 places. Okay, now if the number is smaller than 1, you do something slightly different. The decimal point moves to the right, as you could see in this example below, and the power of 10 is negative. Okay, so in the case down here, we move the decimal place 1, 2, 3 spots to get it to the right of that first non-zero digit. So that means we have 3.8 times 10 to the negative 3. So because we moved it 3 spots, so it's going to be a 3, but because we moved it right, we're going to have a negative exponent there instead of a positive one. Okay? So just take a moment, try out these examples using scientific notation, using what we learned before, and see how you do. Pause the video and see how you do. Okay, and yes, I added in commas on this one just to keep the zeros straighter and help you out. Okay, so the first one here, we're moving the decimal place 1, 2, 3 spots, okay, to the left. So that means we're doing 5.529 times 10 to the exponent 3. Okay, and another way to think about that exponent there is that if you were to take 10 to the exponent 3, that's the number 1,000, and simply multiply 5.529 times 1,000, you would get back to your original number. I'm just going to write that in here. So if we took 5.529 times 1,000, sorry, that's messy, you would get right back to this number right there. Okay, so that's one way to remember what that exponent should be, is it takes you right back to what it was. Okay, the same thing works with negative exponents, but we haven't talked as much about them. Okay, but this exact same process would work. You'll just learn more about negative exponents next year. Okay, so moving along, so 5 million. So we move the decimal 1, 2, 3, 4, 5, 6. So that's 5 times 10 to the exponent 6. Okay, if you just have one digit there, other than 0, feel free to just put 5. You don't have to put 5.0 or anything like that. You can if you want. It's not wrong, but you don't have to put it there. Okay, so this one we're moving 1, 2, 3, 4, 5. But because we're moving it to the right, it's a negative number. Or if you want to consider that if the number's a bigger one here, positive, bigger number, positive, because we have a smaller number, it's negative. Okay, so the negatives refer to the smaller numbers. That's another way you could remember it. 0.4 would be 4 times 10 to the negative 1. So the decimal point is moving only one spot. So you have a negative 1. Okay, so this is going the opposite way, so take a moment and express these using regular notation. Okay, so you're just giving a regular number. Okay, so this one, so it's 10 to the negative 4, so remember we should be getting a smaller number here. So you move the decimal place, so 1, 2, 3, 4, and fill it in with zeros, and you end up with 0.0000358. Okay, and just to double check, if I move the decimal place 1, 2, 3, 4 back, I get to 3.58. So that's what we should have. Okay, 2 times 2 times 10 to the 8 means we're moving that decimal place 8 spots. Okay, I should have picked a smaller number, but I didn't. So I'm sure you all got it though. So 1, 2, 3, 4, 5, 6, 7, 8. We'll get there. So 220 million. So just to double check, if we start the decimal place here, so 1, 2, 3, 4, 5, 6, 7, 8, that would get us to 2.2. That's exactly what we have. Thumbs up for Mr. Shirley getting the right answer, and to all of you who did as well. So 7.7 times 10 to the 0. This is a bit of a trick. Anyone tell me what 10 to the 0 is? Yes, Mr. Shirley, we all can. All right, so remember, 10 to the 0, anything to the exponent 0 is equal to 1. So our answer is just 7.7. It's a bit of a trick question. Now, one quick note, just in the way calculators sometimes express scientific notation, and some of you may have seen this because sometimes when a calculator gets too many numbers added in there, or your basically runs out of screen space, it will give you an answer with an E in it, indicating its scientific notation. All right, so when you see 4.2e plus 3, that's basically meaning 4.2 times 10 to the exponent 3. Okay, that's what that would indicate. Same thing with this, the little up arrow symbol, sometimes called a caret. So 15 times 10 to the exponent 2, that's exactly what it would be. Okay, and in programming sometimes, and depending on what calculator you have, your exponent button might actually look just like that. Okay, so you might be familiar with this one already. But just make note that that's what these numbers mean when you see them. Okay, so thank you for watching. Try out the homework that I've given you and ask me if you have any questions. Thank you very much for watching.